Hello. I'm going to test something out while I'm waiting for people to show up. Trying to see if this displays for you guys. Come on. You can do it. Will you type it into the chat if you guys can see this? Awesome. All right. I'm going to wait for one more person to join up. Cool. All right. So today's lesson is going to be about or it's not really a lesson. I'm just going to tell you about the internal assessment. And then after that, we'll go to the Zoom room, and if you have any questions, you can ask me. And then I anticipate letting you guys go early because really the whole point of this is just to get you guys thinking about the IA. And one other thing I wanted to say is that we had a discussion. We had an IB meeting yesterday. Actually, I'm going to talk about that in the Zoom room. Okay, so let's get started. So I have a PowerPoint for you guys today. Okay, so this PowerPoint is about the IB Physics internal assessment. So internal assessment is typically just called the IA. So this is about the IA, the physics IA. So what is the IA? Well, basically what you're going to do is you're going to develop a research question of the form, how does blank depend on blank? Okay, where each of those blanks is a physics quantity. Okay, so those have to be physics quantities. So it could be, how does the distance that a box slides before coming to a stop depend on the mass of the box? I don't know, something like that. So mass and distance are both physics quantities. Now that research question has to be something that you can actually do at home. This year it's going to be, you're going to have to design and carry out an experiment that you can do that will answer your research question. Okay, so because we're doing distance learning, that has to be an experiment that you can do at home. We can talk about your phones because your phones actually have a lot of ability to take measurements that are relevant to physics. Then you write a 6 to 12 page report on your findings. So basically, You come up with a research question. You develop and do an experiment to answer your research question, and then you report on your findings. Okay. It's supposed to be a approximately 10-hour project, all said and done. So taking the data, analyzing the data, writing the report, all that is about 10 hours. I will grade all of your reports. That's why it's called the internal assessment, because it is it's internally, meaning that within the school, it's assessed within the school. So I look at that, and then I submit your IB, the score that I gave you, to IB. And then IB is going to say, well, we want to look at a sample of the reports that you graded. And then, I was just hearing a weird sound, and I thought it was coming from my computer, but it's a weed whacker. So they're going to say, we want to see, student X's report. And they'll look at student X's report and they'll say, well, Mr. P, you gave this a 20 out of 24, but we think that it's only an 18 out of 24. So we're going to reduce, so they moderate it and they see whether I grade too easily or too harshly, and they apply a correction based on that. If you're an IB student, 20% of your IB score comes from the IA. The remaining 80% comes from the exam that you sit for at the end of the year. But this year being a unique year, I'm going to say something about that in the Zoom room. For all students, regardless of whether you're an IB student or not, this will be a significant semester to grade. Okay, so whether or not you're an official IB student, you still have to do the IA, and it will be scored basically like a midterm would be. So I don't know, maybe it'll be midterm 1 from semester 2. And it'll be due in mid-March. All right. So I want to talk about how is the IA graded. So it's out of 24 points. Okay. And you get 2 points for, and I'm going to talk about what each of these means. 2 points for personal engagement, 6 points for, quote, exploration, 6 points for analysis, 6 points for evaluation, and 4 points for communication. So you get a score out of 24, which I submit to the IB. I would only submit that if you're an IB student. You will receive a separate in-house score, which will count towards your semester 2 grade. So those two scores will obviously be correlated. I'll probably make the IA worth 100 points. So, if you get 50% on your IA, you get 12 out of 24, I might give you 50 out of 100 on your in-house score, something like that. So now I want to talk about how do you score points for each of these different sections. So how do you maximize your personal engagement score? And the main way is to have a creative research question, not something that you can find in a textbook or online. Okay. So showing personal engagement means you have some creativity. You also want to show that you've done some research surrounding your question, to basically make it look like it's an important research question. So you're not just coming up with a question out of a vacuum. You're trying to say like, oh, other scientists are interested in this, and so therefore we should be interested in this. You want to, have a report that is thorough. And another way to show personal engagement is to do some reading about your topic. But I would say the main thing is having a research question that's creative and building an experimental apparatus that is creative. Okay, so creativity is the key to personal engagement score. So what is your exploration score? Well, basically your exploration is where you define what your research question means if it's not clear. And then you design an apparatus that can answer your research question. You motivate why you made your choices. So if you have a certain research question, you want to explain why you designed the apparatus the way you designed it. Okay. You discuss variables and how you're going to measure them, and also you're going to discuss the uncertainty in these quantities. So if you're using if one of your variables is temperature, you want to discuss how you measure temperature, so probably with a thermometer, and you say, oh, the thermometer has an uncertainty of 0.1 degrees Celsius or something like that. Discuss sources of random and systematic error, include diagrams, write a procedure, and this is really important. You don't have to have a hypothesis per se, but you do need to discuss the theory behind your experiment and try to get a relationship between your variables. So for example, if you were studying projectile motion, if that was related to your research question, you might talk about the theory of projectile motion and say, this is what I expect to see in my data. If you were doing an experiment about calorimetry, you might talk about what is the relationship you expect to see. All right, so the analysis is basically what we did with our you might recall the lesson where we talked about different relationships between variables, whether it's linear, proportional, or power law or exponential. So you're basically trying to figure out what is the relationship between variables. You're doing uncertainties. You are making a graph. You're putting error bars in the graph. You're finding a best fit model. In order to do a proper analysis of your data, you have to collect enough data. Okay? So generally speaking, you want to have at least 10 different variable values. So what that means is, going with the example of if we have a box that we slide and we want to see how far does it slide, how does that depend on mass, you would want to try at least 10 different masses for the boxes, okay? And then furthermore, for each of those particular masses of the boxes, you want to repeat it at least 3 times, okay? So, yeah. How do you, so your evaluation is where you talk about whether your experiment was good or not, okay? And you also clearly state what was the apparent relationship between the variables. You talk about, is the apparent relationship between the variables similar to what you discussed in your exploration? Is your relationship a strong relationship? So in other words, does it have a good R-squared value? What were the issues with your experiment? How could you improve it? And so on. What are the extensions to the experiment? Does your experiment lead to other experiments that someone else could do in the future or you could do in the future? These are how you maximize your evaluation score. Communication score, you're going to maximize your communication by using scientific vocabulary, by having data tables and graphs that are well presented, using diagrams or photographs, having a well-organized report, and making sure that it is within the 6 to 12-page limit. So I actually have to grade you down if it's outside of that limit. Okay. It's not changing the slide. Is my computer frozen? Oh, gosh darn it. My computer is trying to do too much right now. Come on, computer. Okay. Gonna wait while my computer catches up. Okay, so we're right here, structure of the report. Come on, you can do it, computer. You can do it. Okay, so here's the structure of the report. It has 4 sections. It has an introduction, where you state the research question and you try to make your research you try to motivate your research question. So why is it important? You have an exploration section where you discuss your apparatus, your procedure for the experiment, and you try to derive a relationship between variables that you would expect to see. You have an analysis section, which includes your graph and your curve of best fit. And you have an evaluation section. So there's 4 sections. So undoubtedly, the most important thing that you do for your IA is come up with a good research question. Okay? If you have a bad research question, there's no way for your report to be good, because it's like the foundation of your report. Okay? So you really need to think about, and I'm going to advise you about your research question, but you really need to be careful that you have a good research question. Sometimes students get fixated on a bad research question. Okay? And then their whole report is just garbage. Okay? So here's some example research questions off the top of my head. How quickly does dye diffuse in a fluid? So this is actually not really a research question of the form, how does blank depend on blank? So if I wanted to put it in that form, I would say, how does the time for dye to diffuse depend on the distance, the size of the container? How does the time for the dye to diffuse throughout the container depend on the size of the container? Something like that. How does the time for the dye to diffuse depend on temperature? How does the time for the dye to diffuse throughout the container depend on the rate at which the container is being stirred? Something like that. Here's a research question. Map out the wind speed at different locations around a fan or near a candle. So how does wind speed depend on location? How quickly does a fluid reach thermal equilibrium? So how does the time to reach equilibrium depend on something? How does the time to reach thermal equilibrium depend on the mass of the system? How does the time to reach thermal equilibrium depend on the composition of the system, etc.? Do additives to a fluid affect its specific heat capacity? So how does the specific heat capacity of a fluid depend on the amount of salt added? Etc., etc. So I took these from one year. The theme was fluids, so I took all these from that. But you don't have. You can study whatever you want as long as it's a physics topic. Okay. So another topic besides fluids that students study a lot is sound waves. Another topic is just like kinematics or projectile motion, things of that nature. I'm waiting for the next slide. Come on, computer. My poor little laptop with a bajillion tabs open. And come on. Come on. Go. It's funny because once I exit out of the window, it immediately updates the... Okay, here are even more ideas, so I'm just going to zoom in. How quick... Oh, that's not even more ideas. How does liquid added affect the coefficient of friction? How does the volume of liquid added affect the coefficient of friction? So there are just a bunch. You can read them. So this presentation is available to you, and I'll show you where in the Zoom room. But there's a sample IA that I wrote that you can look at just to give you an idea of what I'm looking for. There's also a link to a folder with other sample IAs that came from IB. All right. So what is our timeline? Before winter break, I want you to know what your research question is going to be. Okay. Then in mid-January and February, you're going to do the experiment. In late February, you're going to write the report. And then you're going to turn it in mid-March. I will spend the end of March grading your reports. It's a miserable time for me, the end of March. But I will do it because it's my job. Then I have a link for you to make your proposal. So if you already have an idea, you can click that link and submit it. Also, I gave you a link to the so the responses to your proposal are stored in a spreadsheet, and I'm letting you guys view the spreadsheet so you can see what other people are coming up with to give you ideas. And furthermore, I will evaluate the quality of your research question in this spreadsheet. So there's a section of the spreadsheet where I can type in a response to your proposal. All right. You will be submitting your report to ManageBack and also to turnitin.com. All right. So have fun and be creative. All right. So So that's the IA. And so we're going to meet in the Zoom room. I'll answer any questions that you have. I'll answer any questions that you have. I'll show you where that presentation is so that you can access it. And then if there are no questions, I think I'll let you guys go early. Okay, so I'll see you in the Zoom room.